This conference will now be recorded.
Okay, now we have been given here a nice rectangle, and it says that the perimeter of this rectangle is 80 centimeter. The area of a rectangle is a centimeter square. We need to bring this equation, all right, by with the help of this information. Okay, so now you see we know the length is x centimeter, but we do not know the width. All right, so we just give this width a variable for the representation. We call it w. Okay,
Hmm.
so
Okay.
we just go to our board and try to maintain here a rectangle. This is your rectangle, and this is your x in centimeters. Okay, this is your w. I do not know that in terms of x what it is going to be. That's what I'm going to find out. Okay, now area is your a, we know. This is your area a, and the perimeter. What is your perimeter? It is 2 times length plus breadth. Okay,
Hmm.
this is it. So this perimeter is equals to 80. That's what they have said. Okay, so with the help of that, I can find out my w very easily. Yeah. So 80 is equals to 2 times x plus w. So 2 is going to cancel this, 40. So x plus w equals to 40. So I come to know that w is 40 minus x. Okay, so this thing tells me this is 40 minus x. All right, now I'm going to come to my area formula. What is the area of a rectangle? You know that well, it is length into breadth. Yeah,
Yep.
length into width. So area A is equals to length into width. All right, and then you just try to multiply that. X is equals to 40. A is equals to 40x minus x squared. Now you see x squared is along with the negative sign, so prefer to shift your right hand side terms on the left side. Okay, so it is going to look something like this, and this is the equation that they were asking us to bring. Okay, that's it, and it's done. All right.
Wait, it was negative x square, right?
Yeah, it was negative, so you shift it over here, it turns positive then.
Yep.
So that's how it is. Okay.
Yep.
And now you move to your next snapshot and let's see. Um, okay, I need to upload this thing on the board so I could view it properly then. Now we just upload this thing on the board. Okay, now let's say that a car completes a 24-kilometer journey with an average speed of x kilometer per hour. All right, this is your total distance. All right, and this is your v. The car completes a return journey of 200 kilometers with an average speed of x plus 10, and this time the speed is faster. All right, this it. Now show that the difference between the time taken for each two journeys is this. That's what we need to show. Okay. All right. So you know that speed is equals to distance upon time. So this thing shows that time is equals to distance upon speed, and some uh, conventional arithmetic swapping, what we say. So this is it. Now, once when you were starting your journey or going somewhere and covering this 200-kilometer distance, I just say that the time that you have consumed in this journey is T1. Okay, so T1 was 200 upon x. All right. Okay, I call it equation number one. In the same manner, once when you are returning, The time you consumed is t2, and it is this time 200 upon x plus 10. Okay, so you see here denominator is x, here denominator is bigger than x. Okay, so this thing shows that t2 is less than your t1. Clear? Because as x plus 10 is greater than x. That's the reason. So you see
No.
how you're going to take out the difference?
So T2 is greater than
No,
T1 though.
no, t2 will be less than t1 because denominator of t2 is bigger. Bigger is the denominator, less will be the
Oh
answer,
yeah.
smaller will be
Yeah.
the answer. Okay,
Yep.
of course it's a common sense. If your speed is faster, you're going to reach your destination quickly in small interval of time. So this is t2 is less than t1. So you see how you take out the difference of your time, del t. You always write the big time first and the small time afterwards. This is the way how you do. And now you just substitute the expressions of your t1 and t2. Okay. You can take out your 100 common outside, and then you can take out your LCM. Okay. Now
Yeah.
LCM is x times x plus 10. What shall I write in the numerator, son? In the first position of my numerator, what do I have to write? What do I have to write?
X plus 10
Yeah. And here?
minus X.
Yeah. So x plus x and minus x gets cancelled. So you're having 200 times 10 upon x times x plus 10. So it is giving you something that they were asking us. And this is 2000 upon
2000. Yep.
x plus 10 hours. That's it. It's done. Okay. And then find the difference between the time taken for each of the two journeys when x is 80. It's baby question. You see, you just need to substitute x value 80 in this formula, in this expression, in this equation of difference of time. We're
Yeah.
going to get answer in hours, that will be in decimals, so that's what you need to convert in minutes as well. Minutes and seconds. So you need to convert hours time into minutes and seconds. So okay, we'll do that. So it's gonna be, I'm trying to solve it as simple as possible. So this is it. I cancel these two zeros from these two zeros. I'm now having 20 upon 72. I can now simplify this. Okay, so it's giving me 2 times 10. It is giving me 36. I can further cancel 2, 5. I can further cancel it 18.
25.
Okay, so 5 by 18 hours. This is the difference of your time. I need to convert it into decimals. So 5 by 18 is 0.2777. You see, its bracket means 7 is constantly going on. It's a recurring decimal value. Okay, so it's actually 0.2777 and so on. That's how it is going. So I can write as 0.27, and on the 7 I can write dot. Okay, this is in R. I need to convert this now into minutes. Okay, so you know that 1 hour is equals to 60 minutes. I'm now going to multiply this value with my 60. Okay, 0.27 recurring 7 into 60 minutes. So it is going to give me, I'm going back to my calculator value here. It is preserved. I will multiply this with my 60. it is giving me 16.66 minutes. I'm going to convert this 0.666 into seconds later. Okay, so it's 16.6 minutes. So what I do, I just write 16 plus 0.6666. I'm going to multiply it with my 60 so that it will convert. It will be converted into seconds. So
40 seconds.
okay, thank you. So this is so you just say that this is brilliant. That's 40 seconds. So I just say that this is 16 minutes and 40 seconds. That's your answer? Okay. And then you just go to the next question. Okay, the next question is this. All right. So we just download this and upload it on the board. This is now a nice geometry is here. Now we are having here a nice star. Okay, it is what you say. It is a polygon and it is formed by combining 5 congruent kites. Okay, this is kite number 1, 2, 3, 4, 5, and so on. Okay, that's it. Now they have just given us they have just given us that this angle is x. It means this is also going to be x because they are congruent. So this is also x, this angle and this angle, they're also x. So you see, once when you add up all these 5x angles, you're getting 360 degrees, right? So this thing tells me that 5 times x equals to 360. You can get the value of x in this way. Okay, so it is giving me 72. Yeah, 72 degrees. This is your x. And then you need to find the value of your y. So this is your y. And you know that in kite, this side and this side is same in equal in length, and these two sides are equal in length. Okay, so whatever the angle over here is the angle over here. So if this is y and this is also y, all right. So and you know that this is 42, this is 42. So if this is also 42 and this is also 42, because the kites are all congruent, all right. So this is 42, these two are y's, and x you have just calculated. So now x plus 2y plus 42 is equal to 360, because kite is a quadrilateral, and the sum of the interior angles of your quadrilateral is always 360. You know that. So you just sum up all the 4 interior angles and equate them to 360. You're going to get your y now. Okay, so I just say that 2y is, I'm summing up 72 with 42, and then I will shift it on the other side. So 2y equals to 360 minus 4114. You just subtract these two values and divide by 2, you will get your y. Okay, we just come here.
$123.
123 degrees. So this is a nice obtuse angle.
Okay.
Okay, so now we just go to the next question. It belongs to 2016 paper 2-1. I'm going to open my past papers too just to check my answers. And then here a nice rectangular garden divided into different areas is given to us. And then they have given us some information that what is your FG? FG is perpendicular bisector of your BC. Okay, like that is dividing your BC into two equal parts.
Yeah.
And the HJ has center D. This is the arc length, you can see. So this is a sector of a circle whose center is D and radius 20 meters. So you see this is your radius. DJ is 20 meters long, all right? And CE is the bisector of angle DCB. Okay, it is bisecting angle DCB. All right, now this is the information known, and now we just go on. Write down two more statements using loci to describe the shaded region inside the garden. Okay, two. One of the statement is already given to us, that the points which are present in this on this shaded gray region, those points are nearer to C as compared to B, means they are nearer to C and they are far away from your B. For example, if I pick up, this point. Okay, there are millions of my infinite points here. I just pick up one of the point and I just connect this point with my C and then with my B, and I can observe the length, of course. The length of this point from C and its distance from B. Of course, these two lines are there. There's a clear difference. This one is bigger and this one is smaller. So this point is nearer to C and far away from B. That's understood. Okay, I'm going to consider the same point, and I will say that this point is 20 meters greater, more than 20 meters away from your B. Clear?
Yeah.
So you can write down here that from D and J. If you simply write D, that's also okay. If you write both these points, that's also fine. That's perfect. Okay, and then what is going to be your next? We are going to pick up the lines now. Okay, so you see this point is nearer to BC and far away from your AB. Clear? Also,
Yeah.
you can say that this point is nearer to DC and far away from DC. But there will be a contradiction. It is not going to be applicable on all the points then if I just uh, pick up the combination of DC and BC lines, because if I pick up this point, then this point is also, is it satisfying my statement? This point is nearer to BC and far away from DC. Yeah, it is also satisfying. Okay, if I pick up this point, it is nearer to DC, far away from BC. Okay, fine. That's understood. I can use DC and BC combinations too. So you can use DC and BC line combination in your statement as well, and
Mhm.
DC and AB line combination as well. Okay. So if you pick up DC and BC line combination, then you are going to write that the points on the shaded region are nearer to DC and far away from BC. Okay. And if you pick up the combination BC and AB, and you will say that the shaded region points are nearer to BC and far away from AB, or you can also write nearer to BC than AB.
Wait, I can't say nearer to DC than AB.
Well, yes, you can take this combination too. That's nice. Yeah, you can take this one too. BC and AB. Let us further confirm. If I pick up this point, close to AB, close to DC, far away from your AB. We always talk about perpendicular distances of the points.
Yep.
And if I pick up this point, it is nearer to, yes, its perpendicular distance is nearer to DC and far away from your AB. You can pick up this combination
No,
too.
I don't think so. Because FG is perpendicular bisector, so it's equal.
FG is it a part of the shaded region?
No, it's the perpendicular bisector.
No.
So,
Is it a part of the shaded region? Yes, because it is not represented by the dotted line. So it means it is also included. Okay. If it is represented by the dotted line, it means FG is not the part of the shaded region. If it is represented by the solid line, then it means that it is the part of the shaded region. Okay. So, okay, no issue. We can make uh, okay. So it's better not to use this combination. It is going to distract. Better use those lines which are perpendicular to each other instead of parallel lines. DC and AB are parallel lines. Okay. So either use DC and BC or use BC and AB. Are you getting it?
okay, yeah.
Because these lines are perpendiculars. They are perpendicular lines. So this is going to be much better because if you pick up, for example, this point, okay, take a perpendicular distance of this point from your DC and a perpendicular distance from this point to your AB. That makes sense?
Yeah.
Hmm? If you pick
Or,
up this point on the line, it is a part of the
Mhm.
shaded region, right? Perpendicular distance of AB, perpendicular distance from BC. Which line is bigger, which line is smaller? It's very visible. Okay. It's nearer to DC than AB, or if you pick up BC and AB, this is also observed, this is also understood. If you pick up this point, perpendicular distance from BC, perpendicular distance to AB. So this is nearer to BC than AB. It's very understood. So always use the lines which are perpendicular while writing the statement. Don't use parallel lines combination. Okay. But these are the two statements that we have just done.
Okay.
I hope it's clear.
Yeah.
Now you move on.
Wait, can
See,
I check the mark scheme for this?
2 marks only. Two for the statements. One
No,
statement.
no,
That's it.
no, to make sure it's correct.
Yeah, okay. It's 216. Paper 2-1. Okay, I will go to May June 2016 paper. Okay, so May June 2016 paper 2-1, question 14. 14. We go to 14 now. See, bingo.
No, it says TD then 2CB.
Yeah, same thing. DC and
Oh,
DC.
yeah.
Okay. So always use perpendicular lines. Okay, and that's it. All right, now we go to the next question. The next question is this. Okay, so what the issue you're having here in this question? It's
I think it's the second part. I
in the
think I need to.
second part. You have been given here a nice rectangle ABC. We do not know what kind of triangle is this, a right triangle or scalene, whatever it is. It's not mentioned. Okay, so you have done part A here because you know how to construct the angle bisector. Do you? Or do you want me to tell you
Yeah,
history?
I
Okay.
think I can do it.
Okay. Now you see in part B, they are asking us to draw the locus of points inside the triangle that are 3 centimeter away from AC. Okay. 3 centimeter away from AC. All right. For that, for this purpose, I need to upload this. Okay. I need this triangle on the board. Locus of points inside the triangle that are 3 centimeter away from AC. Okay. If I just try to draw a circle having radius 3 and select the center, uh, either point A or point C, I just pick up as a center, for example. If I just pick up A as my center of a circle and I draw a circle of radius 3 centimeter, I'm just trying to see the options here. Okay. So if I just try to draw, but it is going to pick up, uh, and I pick up this arc length, which is the sector of a circle which is inside this triangle. If I pick up this curve only and I erase out the rest of the circle, means the major arc I just remove and I keep this minor arc inside, for example. Okay, this is 3 centimeter, this is 3 centimeter radius. You see all the points which are on this purple arc, they are 3 centimeter away from your AC. But no, it is contradiction. They are 3 centimeter away from the center, not from this radial segment. This circle is not going to be the locus then. I need to think about something else. Okay.
This conference will now be recorded.
If you just simply draw a straight line here in a manual way, okay, use your scale and measure 3 centimeter distance and then draw a straight line 3 centimeter away
Straight
from
line?
here.
Okay.
Okay, so all the points which are lying on this line, they are 3 centimeter away from your AC. So this is the locus of all those points which are 3 centimeter away from the line AC. It's simply a 1-mark question, so there is no hard and fast working involvement here. This is the manual working that you are going to do. Okay, clear?
Yep. Yeah.
Okay. Okay, we go to the next question now. And okay, so what's the issue you're having here in this question?
See, the statement like include the
Okay, so here they have given you 2 lines connected together, and in the part A they were asking us to construct triangle angle bisector BAC, and then in part B they're asking you to complete the statement that the bisector of angle BAC is the locus of the points that are whatever. Okay, you need to fill up this blank. So for that purpose I need to construct here an angle bisector. This is your angle BAC, and
yeah.
you just stretch your compass to some suitable radius. You put your needle at point A, you draw this arc. Okay, and you can maintain the same radius, and you put your needle at this point X, you draw one arc here, and then you put your needle of the compass at point Y, you draw another arc like this. So, and then you draw your angle bisector. You connect your A with your Z. This is the intersection of these 2 arcs. This is your Z, and that's how you connect your A with your Z. And that ray, it will depict the bisector of angle BAC. You have done this already. I need to draw this bisector here, and such that I extend it beyond a little like this. Okay, that is your angle bisector of BAC. Now, what exactly this thing is telling you? This thing is telling you what? It says that all the points which are lying on this bisector, if you try to draw or you try to measure perpendicular distance of this point from AB and BC, if you pick up this point for example, and you try to maintain a perpendicular distance, let me draw it by proper line. The perpendicular distances of this point from AB and BC both will be equal always. Okay? Whenever you draw perpendicular distance, okay, they are always going to be equal. They will always be. If this is 2 centimeter, this is also going to be 2 centimeter. If you pick up this point, draw a perpendicular line or draw a projection on your AB and your BC, they are always going to be equal. My arc is in according to scale. Let me just try to adjust it a little here. That's much better. That's it. You see these lines are equal distant apart from AB and BC and AC. Okay, so it is the locus of the points that are equal distant apart from AB line segment and AC line segment. But that's it. Okay. Pick up this point, perpendicular distance of this point and this point will always be equal.
Okay.
Clear? That's it.
Yeah.
You go on. See the next question now. Okay, now here, what you want me to do?
Just,
You're always stuck in the locus questions, right?
no, I was just unsure about them.
Mm-hmm. You actually need to remember the things.
Hmm.
Let me just minimize the size of this a little. Okay, what they're asking us to do, they have given us a triangle, and they're asking us to construct the locus of points inside the triangle that are 5 centimeter away from B. Okay, from B. This is your B point. You can draw a circle now because this time they're asking you, they have given you just 1 point. So if you draw a circle 5 centimeter having radius 5 centimeter and the center B, just draw a circle here at B of radius 5 centimeter.
Yeah.
Okay, so you can notice that this is 5 centimeter distance and this is your B. You can erase out this major arc, erase out, and maintain this minor arc. Just keep this minor arc inside. Okay, and I recommend that you must not erase out the circle, otherwise the examiner will think that how he has maintained this arc. What was the procedure that he followed? So just keep this arc as it, this entire circle as it is, and try to highlight this minor arc inside the triangle, and then you can say that all the points which are lying on this arc are 5 centimeter away from B. Okay, because this is now the circumference of the circle, and all the points which are on the circumference, they are equal distant apart from the center. You know that. So this is it. So this will be the locus inside the triangle that are 5 meters away from your B. So that's it. And then just a 1 mark question it was. And then the next question is 2 mark. It says that construct the locus of points inside the triangle that are equidistant from AB and BC. Now remember, whenever they talk about locus of points which are some particular distance apart from any point, you always draw a circle. Okay? And when they ask about drawing a locus of points inside the triangle that are equidistant from two different lines, you always draw angle bisector which are present at the intersection of these two lines. Okay, so that at the intersection of these two lines AB and BC, I'm having this angle. Okay, draw bisector of this angle and
Okay.
draw the angle bisector and just show it up.
Not perpendicular bisector.
No, not perpendicular bisector, because perpendicular bisector from C on BC on AB line segment is not going to satisfy this condition. If you draw perpendicular bisector, for example, just look at this. This is your perpendicular bisector. In fact, you are drawing your perpendicular bisector. Wait a second. And perpendicular bisector of which lines? AB and BC? That are not going
AB
to
and
represent
BC.
the locus. That are not going to represent the locus. For example, this is, let me make you clear this. This is the perpendicular bisector of your AB, right? Okay.
Hmm.
So if you pick up any point on this perpendicular bisector, if I pick up this point, its distance from AB, for example, if it's 2 centimeters, and its
Yeah.
perpendicular distance from your BC, is it 2 centimeters? No. No, it is greater than 2 centimeters, right?
Yeah.
So it is not equidistant apart. So perpendicular bisector won't help. Draw the angle bisectors. Whenever they talk about locus of points which are equal distant from two lines, you always draw the angle bisector formed by those two lines.
Hmm.
So draw the angle bisector. I just draw my angle bisector and I extend it. This is my angle bisector. Okay. So all the points which are on this bisector, I just try to draw AB and BC angle is going to be this, not this. The angle formed by lines AB and BC, I thought it was AC. So I'm going to draw angle bisector of this. Okay. Now pick up any point I want. I picked up this point, for example. Its perpendicular distance from AB and BC will be same. Follow projection of this point on both these lines. You see they are same. Okay, they are same. Similarly, if I pick up this point, perpendicular distance measure the length.
Yeah.
It is same. This length and this length, this length and this length. So that's how you draw the locus. Okay, 2 marks is for constructing your angle bisector. Okay, no need to write the steps of construction. It's not required. Okay, and then shade the region shade the region inside the triangle containing points that are more than 5 centimeter away from BC. Okay, so it means the shaded region must be somewhere here, and nearer to AB than to BC. Okay, now I just shade the region here. More than 5 centimeter. I cannot include this pink arc because it is the point on the pink arc is exactly equal to 5 centimeter. Its distance from the B is equal to 5 centimeters, so I can't take this. Okay, so you can you just take shaded region little behind this arc, okay, and little below this angle bisector. Okay, So the shaded region contains all the points which are nearer to AB as compared to BC, and they are more than 5 centimeter away from your B. Okay, and this is it. If you pick up this point, it is closer to your AB and far away from your BC, and is more than 5 centimeter away from your A. So this is going to be your shaded region. Shaded properly, I'm doing it quite roughly, but I hope you can maintain by yourself. This is the
Yeah.
way how you. And then you go to the next question. This time you've collected all the locus questions from me, right?
No, I think that's the last one.
Okay. Okay, so this is your next. Okay, maybe circle theorems might be involved. I don't know. So let's read this question. All the lengths are in centimeters. P, Q, R, S are lying on a circle. P, R, and Q, S intersect each other at Y. P, Y, and Y, S values are given to us. Area of Y, R, S. This triangle is this, and area of Y, Q, P triangle is this. You need to find the value of X. You're going to use the concept of similar figures. Okay? Because you know that this triangle is similar to this triangle. I must write over here. This is my solution. Okay? So I just say that triangle YQP is similar. This is the notation of similarity. Okay? It's similar to triangle YRS. Okay? So this thing tells me that this angle and this angle are same according to your similar triangle theorem, circle theorem of similar triangles. Interior angle S is equals to interior angle P, and interior angle R is equal to interior angle Q. Okay, so the line that is this PY is corresponding to YS because they are carrying same angles on this line. Okay, so I come to know, and I'm taking big triangle in the numerator and small triangle in my denominator. Alright, so I just say that Py upon Ys, Py upon Ys. This is the ratio of the corresponding lengths, and the square of the ratio of the corresponding lengths is equal to the ratio of the areas. Okay, so the area of my big triangle YQP upon area of my small triangle YRS is equal to square of the ratio of the corresponding lengths. I'm going to write my area values and length values and then try to get the value of my x.
Yep.
Here. So let's do it a little here. Let's do a little here. Okay, so YQP is x times x plus 1 divided by 5 upon 12 x times x minus 1. This x and this x will get cancelled as equals to. Now Py is 2x, ys is x whole square. And this get cancelled. I'm having simply 2 inside left. Now this 12 will go here. 12 times x plus 1 upon 5 times x minus 1 is equal to 4. Now you can simplify and get your x answer, because this is going to give you a linear equation. Now I'm shifting this denominator over here. Okay, so now I can write my variable at the left side. This is the tradition of your algebra. You always write the variable at the left side. Okay, so this is giving me 8x times 22. So x is coming out to be 22 by 8. That is 11 by 4. That is 2 whole number 3 by 4 centimeters. Let me check if this is my correct answer. I need to check my answer. And but I do not know from which year this question has been taken. If you have answers at your side, you better confirm this answer. I'm getting curious.
Okay, okay. I'll find it. Past paper. X is right. Yeah, it's 4. X is 4.
And I'm getting 2.6. It means that I am doing something. I've messed up with the calculation maybe. The area of the triangle is big triangle. Twelve plus 20 is 32. My bad, and I wrote 22. Okay, this is 32. Now you're going to get 4. Four centimeters. Done.
Yep.
Okay. Okay, so Okay, the shaded shape is made by joining a square and a rhombus. Alright, if this is your square and this is your rhombus. Okay.
Hmm.
The perimeter of the shaded shape, we need to find out the perimeter of the shaded shape. I think both these planes are shaded, right? So
Yeah.
to find out the perimeter of the shaded shape. So what's such a big deal? You see, it's a rhombus, and rhombus, all the sides are equal, just like square. It is a tilted square. So this is
Oh,
also 5, 5, 5, 5, 5. Okay. So how many fives we are having now? 6 fives. Right?
6, 30,
So the perimeter of the shaded shape is 6
30.
times 5. Yeah, 30 centimeters. That's it. And then we need to find the area of the shaded shape. Area of a square is too easy to find out. As far as area of the rhombus is concerned, you just need to multiply. You can consider any side as a base, and on that base you're going to fall a perpendicular. Uh, I mean, you need to draw the altitude on that base from the opposite side, and that is going to be considered as the height of the of that rhombus. Here they have already provided us, just to save our time. This dotted line is the base. This dotted line has been considered as the base, and on this base you have just drawn the altitude or the height of this rhombus by following a projection from this side on the base, and it is equals to 4.5 centimeters. This is the height. Okay. Now you know
Hmm.
that base is equals to 5. It is equal side. Okay. This is also 5 centimeters long. So you can now easily find out area of the rhombus by multiplying base with the height. So 5 into 4.5. So area will be area of a square
22.5.
plus area 5 into 4.5, area of a rhombus. So 25 plus 22.5. Okay. Centimeters square. This will be your answer.
Yep.
Okay. So, and then we move on, see the next question. Okay, what do we need to do here? Diagram shows a cross section of part of a park bench. Okay, this park bench whose cross section is given to us. It is made from a rectangle of length 32 centimeter and width 8 centimeter, and a curved section, this one, is made from the two concentric arc with sector angle 125, and the radius of the inner arc is 40 centimeter. Okay, from here to here. Okay, and the radius of the outer arc is 48 centimeter. All right, we need to find out the area of the cross section and we need to correct our answer up to nearest square centimeter. So it's too easy. First of all, you need to find out area of this rectangle. Okay, I call it R, not R, I must say AR. Okay, or I call it A1, much better. Okay, and how I'm going to find out area of this this curved section? Find out the area of the inner sector. Okay, find out the area of the inner sector, then find out the area of the outer sector, and then subtract both these areas. You're going to get the area of this curved belt. Okay, then you are going to sum that answer with your A1. That's how we get the area of the entire shaded cross section part. Okay, so let's do it. We just come here. Okay, we are finding A1 now. So A1 is 32 times 8 centimeters squared. Activity calculator. It's going to be 256 if I'm not wrong. Yeah?
256.
Yeah. And now we need to find my A2. This is my A2. Okay, and A2 is obtained by subtracting your outer area and the inner area. You can see that 125 upon 360 pi is coming common, so I can take it out. Okay, so before taking it out, I need to simplify this fraction first. So 125 upon 360, 125 divided by 360 is 25 by 72. This is the simplified form. So I just take it out. 25 by 72 pi outside, and 48 square minus 40 square. Now son, just tell me the answer of this A2.
Okay.
I multiply this with my pi.
$767.9.
Yes, 767.9. 767.9. And I'm going to find the total area, which is A1 plus A2.
$1,023.9, which is 1024. Round to the nearest square centimeter. No. Yep.
Yes. So 1024 will be the answer. Centimeter square. That's how we do, and I hope it's clear. Now we move on to the next question. The last one it is. Okay. This is it. Now Simon has two boxes of cards. In one box, each card has one shape drawn on it, that is either a triangle or a square. Okay. In the other box, each card is colored either red or blue. Let's highlight this thing. Okay. Each card in the first box, you're having cards having either triangle or square on them. And in the second box, you're having cards which are having colors, either red or blue. Okay. Simon picks a card from each box at random. The probability of picking triangle card is T, and the probability of picking a red card is R. Fine. Complete the table for the cards that Simon picks, writing each probability in terms of R and T. Fine. If the probability of triangle card is T, then the probability of square card will be 1 minus T. Okay? And the probability of blue card will be 1 minus R. Keep this thing in mind. Okay? Now, if you are having an event that you pick triangle card and red card, then the probability will be RT, or T into R. You multiply both probabilities. Okay? Square and red is already given to you. Triangle and blue means T into 1 minus R. Clear? And if you're having square and blue, it means you're having 1 minus T for the square and 1 minus R for the blue. So that's it. Done? So
Yeah.
that's all over. Do you have anything else?
Right now, no. Oh yeah, wait.
This is,
This question.
yeah, we are having two more, I guess. No, this is the last one. Okay.
Yeah.
Okay, so what is this? A train travels for m minutes at a speed of x meters per second. This is your time, and this is your speed. Okay. I need to convert my time into seconds because speed is expressed in meter per seconds, right? Find the distance traveled in kilometers in terms of meters and x. Okay. Okay. Give your answer in its simplest form. Convert time either in minutes or in seconds. Okay. I'm sorry. What I need to say is that either convert your time into seconds or convert your speed into kilometer per minute. It's your choice. Okay. If you want to keep seconds as it is, then convert your time into seconds. So you need to make your units same. Fine. So I just say that I like minutes. So I need to convert my speed into kilometer per minutes. Fine. So I just keep time as it is. So my time is m minutes. Okay. And my speed is x meter per second. And I know that 1,000 meters equals to 1 kilometers. Okay. So I just convert this into 1 upon 1,000 kilometers. Okay. Because I know that 1 kilometer is equals to 1,000 meter. So 1 meter is equals to 1 upon 1,000 kilometers. Okay, so I just replaced my meter by 1 upon 1,000 kilometer. And I'm going to replace my seconds. I know that 1 hour is equals to 3,600 seconds. So 1 second will be 1 upon 3,600 hour. Okay, so that's how kilometer, and I don't need hour, I need minutes, I'm sorry. So 1 minute is equals to 60 seconds. I need that, not hours. Too much used to of hours. So let me just go back. So I just say that 1 minute is equals to 60 seconds. So 1 second will be 1 upon 60 minutes. Clear? But that's it.
Yeah.
So this thing now tells me that my V is So I just try to simplify this. 3x upon 50. The speed is 3x upon 50 kilometer per minute. Now I can find out my distance. I can find out my distance now. So I just come here. So I know that v is equals to s upon t. So s is equals to vt. Okay. So v is 3x upon 50 and time is m minutes. So simply kilometer will be left. Minutes and minutes will get cancelled. So the answer is coming out to be 3xm upon 50 kilometers. You can check it out.
Okay. 3mx upon 50.
Yeah. Now when m is 5 and distance s is 10.5 kilometer, you can get your x. They're asking you to find x. So s is 10.5 and is equals to 3 times 5x upon 50. Okay, I can cancel this 10 and this thing tells me that my x is equals to this upon this. You can simplify and you can get your answer in
30.
kilometers and not in kilometers, I must say. X was what? X was your speed, so kilometer per minute. Yeah, okay, so it's 35. And your X was speed. Okay, so that's it. Kilometer per in terms of kilometer per minute. That will be our answer. Check it out, please. Check it out.
Yeah, it's 35.
Okay, so that's it. That's over. That's all over. Okay, son. That's all for today. Inshallah, then I'll see you on
Saturday.
Saturday.
Yeah.
Saturday. All right. Thank you.
Okay.
Allah Hafiz.
Allah Hafiz.